Hi students, in last lecture we see derivatives of logarithmic functions, and now in this lecture we see derivatives of implicit functions. So first of all we know that what is meant by implicit function. So first of all we see explicit function. The examples which are we solved later, these are explicit type functions. So first of all, what is meant by explicit and what is meant by implicit function? So first look at this. Explicit function is what? If a variable y can be expressed as a function of other variable x. That is, we always return function in the form of y is equal to f of x. Then the function f of x is called as an explicit function. The examples all are type of explicit functions. Now, what is meant by implicit function? Now, we have to find the derivative of this type of function. So, what is meant by implicit function? Implicit function is nothing but the function where a variable y cannot be expressed as a variable of x, or x cannot be expressed as a variable of y. It's called as an implicit function, which is in the form of f of xy. The general form of implicit function is in the form of f of xy is equal to 0. Remember that there is difference between explicit and implicit. Explicit means the function in the form of y is equal to f of x, and implicit function, that means this function is not in the form of y or not expressed as a y, so which is in the form of f of xy. So this type of functions is called as a implicit function. In last lecture we see the derivative of this type of function, that means explicit functions. Now we have to find the derivative of implicit functions. So we start exercise 3.4. Exercise 3.4. So first question 1 is there. What is question 1 here? Root x plus root y. Question 1. Find dy upon dx if root x plus root y, which is equal to root a, and we have to find the dy upon dx. Now, which is not in the form of y is equal to f of x. This can be expressed as a function of x and y. So first, write this function as it is. Root x plus root y, which is equal to root a. Now differentiate with respect to x. Differentiate with respect to x. So what is the derivative of root x? We know that the derivative of root x is 1 upon root x. Now this plus sign write as it is. Now what is derivative of root y? If derivative of root x is 1 upon 2 root x. So derivative of y is 1 upon 2 root y, but in this type of root y, remember that now we take derivative of root y. So the derivative of y is dy upon dx. This is the derivative of root y, and this is the derivative of this function y. Now what is derivative of root a? Which is 0, because the root a value is constant, so derivative is 0. Now if we take these two common from this side, and in this side it becomes 0. 1 upon root x, then this term is 1 upon root x plus 1 upon root y into dy upon dx, which is equal to 0. Now here 1 half, so in right hand side it becomes 0. So remaining term is 1 upon root x plus 1 upon root y into dy upon dx, which is equal to 0. So we want only dy upon dx. So first take this side on this side. 1 upon root y into dy upon dx. So here plus 1 upon root x. In this side this is minus 1 upon root x. We want only dy upon dx. So this term here multiply. So therefore dy upon dx is equal to minus 1 upon root x into, now this root y is in denominator here, so in this side it is in numerator. Therefore, the final answer we can write as root y upon root x. So we write minus root y upon x. In same root we write y upon x. This is the value of dy upon dx. Now next question is there. Second, x cube plus y cube. X cube plus y cube plus 4x cube y plus 4x cube y, which is equal to 0. Now again differentiate with respect to x. We have to differentiate these all functions with respect to x only. So what is derivative of x cube? By power function 3x square plus, now what is derivative of y cube? That is 3y square. Derivative of y cube is 3y square, and what is derivative of y? That is again at dy upon dx. Plus, now this 4 keep as a constant, and we have to use product rule here because there are two functions. One is x cube and second one is y. So we keep these 4 as a constant outside. So for use the product rule here. So keep x cube as it is into take the derivative of y with respect to x plus, now keep y as it is and take the derivative of x cube, which is equal to 0 as it is. Now this term 3x square plus 3y square into dy upon dx plus, write this 4 as it is. Now this x cube as it is into, what is derivative of y with respect to x? Dy upon dx plus, now this y as it is, and what is the derivative of x cube? 3x square, which is equal to 0. Therefore this term can be written as 3x square plus 3y square into dy upon dx plus 4x cube into dy upon dx plus, that is 4 into 3, that means 12x square into y is equal to 0. We have to find value of dy by dx. So take dy by dx, terms of dy by dx are common. Therefore 3y square into dy upon dx plus 4x cube into dy upon dx, which is equal to the terms which are plus here. So in this side it become minus. So first I minus 3x square minus 12x square y. Minus 3x square here plus. So in this side it become minus, and this plus 12x square y. In this side it is minus 12x square y. Now from these two functions we take dy by dx out. Dy by dx outside. So remaining part is 3y square plus 4x cube is equal to, take minus sign common. Also we take minus 3x square also common. So in bracket we get 1 plus 4y. In this side 1 plus 4y. Therefore dy upon dx is equal to dy upon dx is equal to, so we write this term again as it is, there is no problem, minus 3x square into 1 plus 4y divided by 3y square plus 4x cube. We write this term as it is, or we can simplify it, there is no problem. So the value of dy upon dx is minus 3x square into 1 plus 4y divided by 3y square plus 4x cube. Now third question, x cube plus x square y plus x square y plus xy square plus y cube is equal to 81, which is implicit function. So first differentiate with respect to x. Differentiate with respect to x. So what is derivative of x cube, which is again 3x square plus, now again there are two functions x square and y, so use product rule here. So keep x square into, take the derivative of y plus keep y as it is into take the derivative of x square plus. Now we use the product rule here. Now again here we have to use product rule. So keep x as it is into derivative of which term? Y square plus. Now keep y square as it is into take the derivative of x plus. Now y cube. So what is derivative of y cube? 3y square into derivative of y with respect to x is dy upon dx. Therefore, this 3x square as it is plus x square into derivative of y dy upon dx plus y as it is into derivative of x square is 2x plus x as it is derivative of y square 2y into what is derivative of y dy upon dx. Again this y square as it is, and what is derivative of x is 1 plus this term again as it is. Now simplify this 3x square plus x square into dy upon dx plus 2xy plus 2xy into dy upon dx plus y square plus 3y square into dy upon dx, which is equal to 0. Now the terms in this dy by dx keep in this side, and the terms which are not multiplied by dy by dx take on this right hand side. So the terms in this side are x square into dy by dx plus 2xy into dy upon dx plus 3y square into dy upon dx. In this term there are dy upon dx, so keep this term in this side. Now minus 3x square, so this is minus 2xy and here plus y square, so in this side it become minus y square. Now take dy by dx common from these two functions. So dy upon dx into here x square plus 2xy plus 3y square is equal to, now we take minus also common, so 3x square plus 2xy plus y square. Therefore we have to find dy by dx, so this multiply term in this side it is in denominator. Dy upon dx is equal to minus 3x square plus 2xy plus y square divided by x square plus 2xy plus 3y square. That is the value of dy upon dx. Now question number 2 is there. Question 2. Find dy by dx if y into e raised to x plus x into e raised to y is equal to what? Y into e raised to x plus x into e raised to y is equal to 1. So right, differentiate with respect to x. Differentiate with respect to x. So again we use product rule in these two functions. First keep y as it is into derivative of e raised to x plus e raised to x into derivative of y. We use product rule in this side plus again use product rule here, x into derivative of e raised to y plus e raised to y into derivative of x, which is equal to 0 because derivative of 1 is 0 since it is constant. Therefore y into what is derivative of e raised to x, that is e raised to x plus e raised to x as it is derivative of y dy upon dx plus here x as it is. Now derivative of e raised to y is e raised to 1. That is the derivative of e raised to 1. So what remaining part? Derivative of y. So what is derivative of y? This is the derivative of e raised to 1. This is the derivative of y with respect to x plus. Now again take the terms of dy by dx. E raised to x into dy by dx plus x into e raised to y into dy upon dx is equal to minus y e raised to x minus e raised to y. Now take dy by dx, common this from in bracket e raised to x plus x into e raised to y is equal to, again take minus sign outside, y into e raised to x plus e raised to y. Therefore dy upon dx is equal to y e raised to x plus e raised to y divided by e raised to x plus x into e raised to y. Again this is our dy upon dx, which is the derivatives of implicit functions. This is not in the form of y is equal to f of x. That means it can be in the both form x and y. Second, x raised to 1 is equal to e raised to x minus 1. Or we thought also a third example. You should try second, which is very easy. We should try xy is equal to log of xy. Xy is equal to log of xy. So differentiate with respect to x. So again we have to use product rule. X into derivative of y dy upon dx plus y into derivative of x is 1 is equal to. Now this is in the form of log f of x. So derivative of this function log is 1 upon f of x. So 1 upon function, instead of function there is xy into multiply the derivative of function. So function is xy here. Therefore x into dy upon dx plus y is equal to 1 upon xy in bracket. Find the derivative of these two terms x and y. So x into derivative of y dy upon dx plus y derivative of x is 1. Therefore x into dy upon dx plus y is equal to, now we multiply this 1 upon xy in these two functions. So x upon xy, so it becomes 1 upon y into dy upon dx. Since this xx after multiplication, the xx will get cancelled, that is x upon xy. So this x will get cancelled and the remaining is 1 upon y into dy upon dx. Plus, now again multiplying by 1 upon xy into y. So y will get cancelled and the remaining part is 1 upon x. Now this term 1 upon y into dy by dx take on this side, that is left hand side. So x into dy upon dx minus 1 upon y into dy upon dx is equal to, keep this 1 upon x as it is and it's plus 1, in this side it becomes minus 1. Therefore now take dy by dx outside. Therefore dy upon dx is equal to into x minus 1 upon y is equal to 1 upon x minus 1. Therefore dy upon dx. Now we simplify this term by cross multiplication. So x into y xy minus 1 upon y is equal to, again we simplify this, 1 minus xy divided by x. Therefore dy upon dx is equal to 1 minus xy upon x into, now this multiply term in this side it is in denominator, so y upon xy minus 1. So we take 1 minus 1 common, so this term will become become same. Minus 1 minus y into 1 minus xy and minus x into 1 minus xy. So by multiplication by minus 1, so minus 1 and minus minus it become plus 1. Now these two terms become same. So answer is minus y upon x. For cancelling, we take minus 1 common from this xy minus 1. Since now these two terms are become same, 1 minus xy, 1 minus xy will get cancelled and the minus sign is remaining here. So the answer is minus y upon x. Now we take one example in question number 3. The second question from question 2, you should try, and if you not understand then please ask me. Next question 3 is there. This type of question are very important. The questions are asking for 3 marks. If x raised to 5 into y raised to 7 is equal to x plus y raised to 12, then show that. This is very important example. In the book there is same problem. There is same solving problem is there. On page number 95. You also solve this problem in your notebook. X plus y raised to mn. These two problems are very important. Then show that dy upon dx is equal to dy upon dx is equal to y upon x. There is solved problem in your book on page 95. Now we solve these problems which are in exercise. So what is given here? X raised to 5 into y raised to 7 is equal to x plus y raised to 12. Now these type of examples we are solving by using logarithmic functions. So first we are taking logarithm on both sides. Very important problem. Both are logarithm on both sides. 3 or 4 marks it will be asked in exam. Taking logarithm on both sides. So log of x raised to 5 into y raised to 7 is equal to log of x plus y raised to 12. So after applying log, there is which is in the form of log of mn. So we write is as log m plus log n. Therefore we write this term as log x raised to 5 plus log y raised to 7 by using product law of logarithm is equal to, now by exponent law of logarithm we write 12 into log of x plus 1. 12 into log of exponent law. By using exponent law of logarithm. Again we use here exponent law. So log x raised to 5 can be written as 5 log x plus log y raised to 7 can be written as 7 log y is equal to, this term keep as it is, 12 into log of x plus 1. In these two terms we use exponent law of logarithm. Now this is in the simplified form, so we differentiate with respect to x. Differentiate with respect to x. So this 5 is constant. Now what is derivative of log x? 1 upon x plus this 7 is constant. What is derivative of log 1? 1 upon 1. But we differentiate with respect to x. So this is derivative of log 1 into multiply the derivative of 1 is equal to, now this 12 is constant. So what is derivative of log x plus 1? 1 upon x plus 1. And find the derivative of x plus 1. So what is derivative of x? 1. And what is derivative of 1? dy upon dx. Now again we simplify this. 5 upon x plus 7 upon y into dy upon dx is equal to 12 upon x plus y plus 12 upon x plus y into dy upon dx. Therefore, 5 upon xy. Now we take terms of dy by dx. So 7 upon y into dy upon dx minus 12 upon x plus y into dy upon dx is equal to, now this 12 upon x plus y keep as it is, minus, there is 5 upon x, so in this side it becomes minus 5 upon x. Now take dy by dx common. So 7 upon y minus 12 upon x plus y is equal to, now we multiply this term, 12x minus 5 into x plus y divided by x into x plus y. Therefore, now again we simplify this bracket. So 7 into x plus y. So we multiply directly 7 into x plus y, that is 7x plus 7y minus 12y divided by y into x plus y is equal to, again we simplify this, minus 5x minus 5 upon x into x plus y. Therefore, dy upon dx is equal to, now 12x minus, first we simplify this, 7x plus 7y minus 12y, that is minus 5y upon y into x plus y is equal to 12x minus 5x, that is 7x minus 5y upon x into x plus y. Now dy upon dx is equal to 7x minus 5y divided by x into x plus y into this term which in numerator, in this side it is in denominator, divided by 7x minus 5y. Therefore the same terms will be cancelled. 7x minus 5y, 7x minus 5y, and x plus y, x plus y. Therefore dy upon dx is equal to y upon x, which we have to prove. So right, hence it is proved. Hence it is proved. This problem, which is in the form of like constant or which is in the form of mn, which is very important. First we use logarithm and then we take a differentiate with respect to x. After differentiating, take the terms which are multiplying by dy by dx common and then simplify the question. So the remaining questions I will giving you answers. And in next lecture, we start our next point, derivatives of parametric functions. Thank you.